I'm Anil Kumar. Welcome to my series on trigonometry. Let me thank all the subscribers and viewers for watching my videos, and special thanks to Rhoda from Hyderabad, who has shared some questions from her previous board exam test papers. Here are 4 of them. I'll take some more later in some other video. These questions I have modified and placed them like multiple choice so that they can be very helpful for students who are thinking of taking admission to American universities. So in SAT, you could get similar questions. So keep that in mind. Now, the 4 questions here are relatively simple. You can always pause the video, answer these questions. Before answering, I'll give you a few basic concepts so that you get ready on this particular topic. And then we'll take up some challenging question on solving acute angle triangles using trigonometry. So let's begin with the very basic concept, and that is we're trying to solve a right triangle, for example. In that case, in a right triangle, if we are given let's say the corners of the triangle, the vertices are A, B, and C. The angle here is theta. Then we can find the trigonometric ratio sine as ratio of opposite over hypotenuse, cosine as ratio of adjacent over hypotenuse, tan as ratio of opposite over adjacent, right? So in short, we can find sine theta as equal to CB over AC. Cos theta will be equal to the adjacent side, which is between the angle and 90 degrees, will be AB over AC, right? Now tan ratio is ratio of sine and cosine. So let's see how tan ratio looks like. Tan theta is equal to opposite over adjacent, which is CB over AB. Now tan is also equal to sine theta over cos theta. So it's the ratio of sine theta and cos theta, right? In case of lines, this theta also gives you the angle which line makes with the positive x-axis. So sometimes tan theta, which is rise over run, reminds you of, let me write down here in a different ink so that you remember that tan theta also could be seen as rise over run. So that tells you that it is equal to slope of a line. Now these are important things to remember. Another very important thing is, if you look at this angle, theta is here. What should be that angle? This angle should be 90 minus theta. Do you see that part? So if the relation between 90 minus theta and theta is straightforward, we could also write that relation here. So these are some formulas which you might need to solve these questions. So if I want to find what is sine 90 minus theta, that should be equal to cos theta, right? And cos 90 minus theta is equal to sine theta. We call them cofunction identities, right? These are called cofunction identities. And while answering, I'll tell you something about our special triangles also. So with this background, I think you can pause the video, answer all these 4 questions, and then look into my suggestions. Now, let's try to solve them one by one. The very first one here is sine theta equals to sine A equals to cos A, then find the angle A. So what we are given here is sine A equals to cos A. We could divide by cos A both sides, right? So we get cos A. When you divide by cos A both sides, what do you get? Sine over cos is tan, correct? So we get tan A equal to 1. So that is where what I shared with you earlier. Do you see this part? So tan theta is ratio of sine theta and cos theta. So that helps. Perfect. Now, When tan A equals to 1, you can use your calculator and find inverse angle. So we can say that angle A is equal to tan inverse of 1, and you will get 45 degrees as your answer. So option C is the right option, correct? The other way is to use special triangles, right? So let's talk about special triangles also. Now I'll share with you two special triangles, one with this 45 degrees, right? So if I have a right triangle where the two sides are equal, in that case, this angle here has to be 45 degrees, correct? Since sum is 180 degrees, right? 45, 45 and 90 gives you 180. Now in this particular case, the ratio, we can say if these two sides are 1 and 1, then that side is square root of 2. So tan theta is the ratio of these two sides. So tan 45 is 1, right? So from special triangle, you get the value of tan 45. Perfect. So from here, we can get our result. This is very important to remember. Question 2. If sine A equals to 0.6, then find value of cos 90 minus A. So remember this thing? Cos 90 minus theta is same as sine theta. If we are given sine A, we are looking from this side, correct? But if you look from the other side, that becomes cos. So if sine A is 0.6, then cos of 90 minus A should also be same, right? So it is option B. Perfect. So remember, cos of 90 minus A is always equal to sine of A, right? Remember, we are working in acute angles. So we are working in the first quadrant in this particular case. So I hope these concepts are absolutely clear, and you see how the information provided to you earlier helps in answering all these questions and any related question which we'll be talking about. Now, let's take a small break, enjoy the weather of Canada, and then we'll get back to the solution of question 3 and 4. I hope that sounds good. I hope you enjoyed the video on snowfall. It's really beautiful out here with temperature reaching below minus 15 today, approaching minus 20, and it feels like minus 29, bone chilling cold. Well, let's get back to the classroom and answer these questions. Question number 3. If tan x is equal to square root 3, then find the value of 1 plus cos x. Right. So tan x is square root of 3. Let's make our triangle. Now this is also a part of a very special triangle. When we say tan x is square root of 3, let's say this angle is x, tan is ratio of tan x is equals to opposite over adjacent, correct? These two sides. So square root 3 is the opposite side and adjacent is 1. Now that gives you hypotenuse as ratio of, square root of this square plus 1 square root, correct? So which is 2. So this side here is equal to 2. Now this is a very special triangle. We call this as 30, 60, 90 degrees. 30 degrees, 60 degrees, 90 degrees triangle, right? So this angle here is actually 60 degrees angle, okay? Now, let's get back to the question. Tan x is square root of 3. That means is the ratio of opposite to adjacent. From here, you can find hypotenuse, which is 2. Now, let's evaluate 1 plus cos x. So 1 plus cos x, cos of x is going to be half, 1 over 2, right? So it is 1 plus half, which is same as 1.5. So B is the right option. Do you get it? Again, you could use this special triangle 30, 60, 90 to answer such questions. So many times in your test papers, you'll be working with 30, 60, 90 triangle or 45, 45, 90 triangle as we did earlier. Now question number 4 is slightly difficult. We are given that 4 of sine 2x minus 1 equals to 0. That means 4 of sine 2x equal to 1, or we can say sine 2x is equal to 1 over 4. Now, if the question is to find cos 2x plus tan 2x, what we can do here is just sketch a triangle. So when we say that this angle 2x is equal to 1 over 4, sine of this angle, that means opposite side is 1, hypotenuse is 4. We can find this side, which is 4 square minus 1 square, square root. 16 minus 1 is square root of 15. We get that side. Perfect. Now you can evaluate what is cos 2x plus tan 2x, right? Let's find what is cos 2x plus tan 2x. Now from here, you can see that cos 2x is 1 over square root of 15. That is the tan 2x. Let me rewrite. Cos 2x is square root of 15 over 4, right? Plus tan 2x is 1 over square root of 15, correct? So that gives you the value as 4 square root 15. Cross multiply, you get 15 plus 4, right? So you get 19 over 4 square root 15. Now you can use calculator to find this answer. So we have 19 divided by 4, and then we'll divide by square root of 15, which is in decimals equal to 1.2, right? So we get this as equal to 1.2, and therefore option B is the right option, correct? Now let us extend this question. And now we are extending it to find x, right? So let's find x. So we'll actually get back to sine 2x, where x is less than 90 degrees, right? And let's say greater than 0. Okay, so we have sine 2x equal to 1 over 4. That means 2x is equal to, 1 over 4. That means 2x is sine inverse of 1 over 4, right? So 2x is equal to, let's use the calculator, find sine inverse of 1 over 4. Shift sine and 1 divided by 4 in the bracket. We get 14.4775. X is half of that, right? So 14.4775 divided by 2. So we'll divide this by 2 to get our answer, which is 7.23, or approximately 7.2 degrees. So x is 7.2 degrees in our case. Perfect. So that is how we can actually solve these questions. I hope you learned some very basic concepts. Now in the next video, we'll take up evaluating trigonometric ratios for different angles. and I hope you find this interesting and useful. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.